Hi guys, how you going? It's Mr. Bennett here. Just want to go through some questions to do integration by substitution. Now, why would you need to use this? Well, the cases when you need to use this are going to be if you get something like in the form of most of the ones that you have are in the form of ax plus b. So if it's not in the form of ax plus b, then you cannot use any of the other rules. So remembering, if we've got something like e to the ax plus b or ln of ax plus b, or even with our function to the power ax plus b to the power of something, if it's not in that form, then you can't use the rules that we've learnt so far. So we have to do a thing called integration by substitution that will allow us to find the integrals. Now, we're looking at exercise 6E4, and I'm going to go through a couple of examples for you just to show you how that works. Now, the key thing is, the main function that we're looking at is the thing in here that we need to make our u value. Right? So it's either the something that's to the power of something. So our first step will be to say, let u be equal to x squared plus x. Alright, so in terms of that, I need to find my du dx. And that's equal to simply going to be the derivative of that, so that's 2x plus 1. Alright, so what we're looking for here is, in fact, we're using our rule up here, the function times by the derivative du dx times by dx. Now, obviously, the dx's go out and leave us with the function f of u with respect to du. Alright, so this is what I'm looking for. So I need to identify in here that this thing is in fact my du dx. So if we look at that, that is in fact this here. So that is my du dx. So that's what I'm looking to try and use. So what I can say here is, and I'll write it a slightly different way, this is my u value, so therefore I'm going to write that as simply u to the power of 5 times by du dx, and then we're doing that with respect to that dx. So looking, in fact, the du dx is in fact the 2x plus 1. Now what it allows me to do is then write this is equal to the integral of u to the power of 5 with respect to u. So we're differentiating that with respect to u, and so therefore when I do that integral, right, that's going to be u to the power of 5 plus 1, which is 6, all over 6 plus c. So that's going to be equal to, now I know u value is in fact x squared plus x to the power of 6 all over 6 plus c. So then I've got my answer. Alright, so that allows you to work with things that are not in the form of ax plus b. Let's go to our second example, looking at this one here. Obviously, the thing that we need to recognise is this has been the u value that I'm actually looking at there. Right, so we will say let u be equal to, in fact, 5 take 2x squared. I'm going to do the derivative of that, and that's equal to simply minus 4x. So I've got to look in here, and we're going to think about where can I get this value inside my bracket. Now, I can see that's an x value there, can't I? But it's not minus 4x. So what I really want to do is I'm about to write this as the integral of minus 4x all over 5 take 2x squared to the power of 3 dx. So I've got it really in terms of what I need there. Now I can't just put the minus 4 in there because it's obviously not there. So I have to times that at the side here by minus 1 on 4. So if I times minus 1 on 4 over minus 4, then that's going to give me 1. Alright, so now I can write this here is equal to minus 1 on 4. The integral of simply u to the power of minus 3 times by du dx times by dx. Right, so I can cancel my x's out. Now, at this particular stage, I think I might just go straight and do the derivative. And so that's going to be minus 1 over 4 Now, in terms of adding the power, so that's going to be u to the power of minus 3 plus 1, so that's going to be u to the minus 2 all over 2 minus 2, and then plus c. So we can simplify this. Now the 4 and the 2 are going to get times together, and the minus is going to go out there. So therefore that's going to be simply u. We know u is equal to 5 take 2x squared to the power of minus 2 all over 8. And then that's going to be plus c. Now you could bring that down if you wanted one more step. So you can say it's equal to 1 over 8, 5 take 2x squared squared. Alright, and then plus the c value. You can't forget the c value there. Alright, so that's a second example. We're going to look at something just a little bit harder. And the choices that you really got to make here are not really all that great. So if it's something like a value to the power of something, then in this case when we've got an e, our power bit's going to become the power of the e. Alright, so that's what we're looking at, because remember it's ax plus b. We can't do the derivative because of that fact. So, and we're expecting this to be part of our du dx. So we know this should work out, so let's have a go at it. So let's let u be equal to, u is equal to x take 1 all over x. Alright, so that's what that's equal to. If I take the derivative of that, so du dx, that's going to leave me with, now I'm going to have to use the, well, probably using the quotient rule might be the easiest thing. So if I do the derivative, the first thing, it's going to be 1 times by x take 1 times by the derivative of this, which is in fact equal to 1, and then all over x squared. So that what that will leave me with is equal to x take x. Now negative 1 is plus 1, and that's all over x squared. That's going to cancel out, and that will leave me with a value of 1 over x squared. Right, so can you recognise this thing here as being 1 over x squared? Well, that is in fact my du dx. So this simplifies quite nicely as equal to the integral of e to the u times by du dx times by dx. Now keep in mind, when you're doing this, you know the sort of thing you have to do. You have to trust that you'll get there by yourself. So have a go at it, see how you go with it. If you don't quite get there, you might have to go back and try it again. But really your choices are fairly limited with this type of integration. So when I do that, we know e to the u is simply going to be e to the u plus c is my differentiation. So that's going to be simply e to the x take 1 all over x plus c, and that's my answer there. All right, now the secret to these questions is to simply look at what you've got inside your integral. If you don't have anything in the form of ax plus b, then, or if you've got something which has got multiple terms in there and you can't simplify it easily, then you're thinking only way I'm going to be able to do this question is by using substitution. Alright, so I think it will be pretty obvious when you have to do it. So remembering, if it's not in the form of ax plus b, you must use this particular technique. Now, good luck with those questions from 6E4. Have a go at them. Have a go at a couple of those tonight before you come to school, and then I will help you if you need some help with that. Alright, good luck with those. See you for now.